So here's my Mobius strip again. So I'm going to start sort of cutting it in half. So let me just make a little snip here. And then I'm going to try to do that. Let's see. So.
Sir, aren't there two sides because you have the front and back, right?
Sorry?
So you have the front and back, right? So isn't it two sides?
No, that's what. So if you try to color a Mobius strip, you'll find that, you know, you've colored the whole thing. So it's a one-sided surface.
Yeah. Okay.
Okay, so yeah, so it's a, so now if you, yeah, so when you cut it in half, okay, so I'm just taking the center and just kind of cutting right through the center. Okay, so just cutting exactly as you would try to cut things in half. Okay, sometimes you might need to change your, now when you cut it in half, you still get something which is connected. Okay, so it doesn't cut into two pieces. Okay, and this is what we already saw, you know, in terms of the diagram. So let me come back to the thing here.
Excuse me, sir?
Yes?
This seems to be one full twist. I don't know. I'm just guessing.
Yeah, so let me sort of go back to the diagram that why did I call it a half twist? Well, it's because, you know, so what we did is this arrow pointing up, you know, it goes to some arrow pointing down, right? Now, when you think about it, it's a 180-degree turn. Okay, so by a full twist, I would mean it's a 360-degree turn. Okay, so when you kind of come back, so I'll talk about that in a little bit. Actually, so maybe now is a good time. So right, so this is what I call a half twist. Some people might call it a twist. Okay, just to kind of you are twisting it, but so I'm calling it a half twist because you do 180-degree instead of 2. So let me actually, since you've raised the question, so let me sort of ask, what happens when you do two half twists and glue? Okay, so in other words, if I want to draw it in terms of a diagram, maybe sort of this was, you know, sort of one of my half twists, and then, you know, sort of I do it again, and that's my, so now this time this arrow and this arrow would be the same, you know, sort of direction, right? So that this is a one complete twist. It's a 360-degree twist, and then I glue. This is what you know, we are after. Well, so before we do it with a piece of paper, what do you expect now? So the point is that in terms of a diagram, a topological, you know, in topology, if you want to draw this diagram, so what happens is, you know, this part. So let's say, so I kind of, you know, look at it in two halves. So I draw this red line here. Now, if I think about it, this red line, so far it's just like one of our Mobius strips, right? So this guy and let's say, so I draw a red line here. So maybe this guy. So this guy is one of our Mobius strips that we already had, and then we took we're sort of gluing another one, right? So we have sort of have another another Mobius strip where this side is let's say glued with a half twist there, right? So so we are kind of taking these two Mobius strips and then cutting along the red edge and identifying these red edges, right? So when you do that, when you identify these red edges, then, well, the red edges, they kind of disappear. They're no longer, you know, relevant because you've glued along them, right? So they are in the interior. So what you get is something like this, right? And what is this? Well, this is nothing but our good old cylinder, right? So where you didn't twist at all. right? And then you came back. So now, so topologically, what you get is it's something which is topologically equivalent to a cylinder if you do two half twists. Okay. Uh, and what happens when you cut that? Well, when you cut that along the middle, this central line, if you cut it in half, then what you get should remain connected, right? Sorry, so now you're doing two half twists, so now it will no longer be connected. It's like, you know, a cylinder, right? So a cylinder, if you cut along the central line, you get two pieces, right? So it's no longer going to be connected, because this time if you're an ant and you kind of you know, sort of go along this way, then this part is glued to this. So you kind of, you remain on this one side of this red, you know, sort of line along which you cut. You can't really cross over, right? So, so this is what you expect. You expect, you know, sort of two connected pieces now when you cut it in half. But there's a catch. So let's actually sort of try to see it. So let me share this video, the screen again. So this time, I already have a strip of paper. Let me take one of the strips that I already have. And now I'm going to, you know, make two twists, right? So maybe let me take a slightly thicker one so that it's easier to, maybe this is okay. So let me make two half twists, right? So this time I'm going to apply glue maybe on the other side, right? So because when I do two half twists, this side is what is going to glue up. And what I do is, so this time one has to be careful. So this is one half twist, and then I do another one, right? So this is coming here. So this is 180 degree, and then you have another 180 degree, right? So then you're back to this, and then I glue up the thing. So this is now my, you know, sort of double twisted thing, or, you know, two half twists, if you like. All right, so now when I cut this into half, okay, so once again, I'm going to just snip a little here, and then I'll put in scissors and keep going. So let's see what happens. So I'm going to continue. I'm just cutting it exactly in half. Okay, so we're almost there. Okay, so you see now that you do get two pieces, but they are interlinked. Okay, so I said there was a catch. So just like a cylinder, you do get two pieces, but they are, you know, like they're linked. You can't kind of separate. And moreover, if you sort of think, if you see carefully, each of these pieces. Let me tear off one of them and see. Let me tear this off. So this piece looks like it's like a Mobius strip again, right? I mean, this is sort of funny. And so what's going on here is, let me share my screen again. So the point is that, I mean, so you see that it's not exactly like a cylinder like this, like we did topologically, because we are actually, you know, doing this in R3, in Euclidean space. Okay, so we kind of have this. So when we draw it in as a diagram on this as a topological space, it is indeed topologically equivalent to an annulus, but as something that is sitting inside, you know, the Euclidean space, you know, the space that around us, right, R3. it is a different, it's a different surface. Okay, and this is something that I'll leave you to sort of think about. In fact, I mean, you can do more twists, right? So now if you do 3 twists, right, and then cut it in half, then you expect, from the diagram, that it is now going to be topologically equivalent to the Mobius strip again, right? So if you do odd number of twists or odd number of half twists, this edge is going to go upside down to this edge, and then sort of just like a Mobius strip, when you cut it in half, you remain connected. Okay, but this connected piece would look like you would have some twists, on it. So I'll leave you to figure out, how many twists, happen. And so if you have an even number of twists, then you cut it, you get 2 pieces. How many twists are there in each? And, there are various questions one can sort of ask, and then you can sort of try to play around with these paper and scissors and try to answer them. Okay, so, and in fact, maybe in the last session on not theory, I'll be revisiting this again, because what is really happening is that we are actually sort of getting something like knots in Euclidean space. So there's something that topologists care about, and it's sort of a very interesting sort of application of all these concepts is sort of understanding how things embed in space and things like knots and then so on, and this in turn has many applications. Okay, so this sort of thing is used in robotics and motion planning. So suppose you have something navigating through terrain, a robot navigating through terrain, you'll have to sort of plan out the motion, and then you have some kind of phase space where you do this. So there are these shapes that are involved in the study of, in many fields, in the study of be it robotics and be it physics and so on. And so topology sort of enters into all these fields. And so it's an exciting sort of subject that has many applications. Okay, so this is what so these half twists to a strip of paper do. So there's another paper cutting experiment that we'll try to first do on this on paper on sort of theoretically, and then try to do it in practice. Another paper cutting experiment